Okay, very happy to have this kind of speech. My speech topic is the modern OS challenge and the openEuler solution. Okay, before I do the speech, I think Yanjun has answered the question, what is the openEuler and what is the OpenHarmony? I can do a very brief introduction. OpenEuler is for the, you can think it's to be for to be scenario, and open harmony is for to see scenario. So that is the simple distinguish. Okay, so why talk about the challenge for the modern OS? It's a lot of challenges, or we have different problems to resolve. It's a very big topics, but nowadays I just want to mention two challenges for the for the OS industry. The first one is the fact that the development of chipset meet the slow development of the OS. So that means for my view, that the fast development of the chipset has made the OS industry face very big challenge. The second challenge is that the gap between the server cloud and the embedded system. So that means we have used different way to handle this kind of two scenarios. But how to reduce the gap between reduce the gap, that is also the challenge. I will do more explanation in the next slide. So for Linux, for OS now we refer to Linux. Linux has developed very long time, over 30 years, and it looks very good. I think it is the most successful OS system until now, and for industry side, and everything looks fine. But does anyone think is it good enough? So maybe someone say it's not good enough, but there's some minor issue which can fix. It's not so fast or too complicated or something like that. But if we came to the detail, we can find the things not look so good. Kernel is very important for OS, right? And especially for the hardware, for the chipset vendor. Actually, kernel is the interface for the hardware and the software. You can see the picture that the kernel contact with the physical hardware, and also link with the user space with the application. So is enough. If suppose you are a chipset vendor, is it enough just to put your patch or code into kernel? For example, you just put your driver or patch into the kernel, and the kernel accept that fine, everything goes well, and your work stopped. So it sounds good, but actually in industry area, it's far more complicated. It's not end. Why? I will give you an example. Suppose you have a new chip. You are a chip vendor and you have a new chip. Now you will follow those steps. First, you should ensure patch accepted by the kernel community. Usually, this is not an easy way. You need to wait a long time to be accepted. And then if your patch came into the kernel, you need to make sure the OS vendor accept again. So what does it mean? The OS vendor also need to adopt those kind of patch into their product, to integrate those patch into their product. And then the OS vendor will deliver those features to customer by OS vendor. So every step will spend a lot of time. But everyone knows that usually a chipset has about 3 years life cycle. During those process, it will spend maybe 1 year or 1.5 years. So half of the chipset life cycle, they spend a lot of effort on this kind of process. And if we consider more, kernel has 4.0, 4.1, and 5.1, 5.2, 6.1, 6.0, and continue to increase. So you have to support a lot of kind of version for the kernel. And also, this is just the kernel community version. For the OS vendor, they will release, for example, 6.0 release and 7.0 release. Each release may adopt a different kernel version. And then in one release, for example, the 6.0 release, it has a service pack 1, service pack 2 as P3, a lot of service pack. And finally, there are a lot of OS vendors. So suppose you are a chipset vendor, how complicated things you are facing. So that is a problem. And also, suppose you are a guy, the administrator who is in charge of maybe 10,000 machines or 100,000 machines or even 1 million machines. So you will, what you can face? You will face a lot of very complicated scenario. For example, you have to face the CPU, GPU, DPU, TPU, XPU, and a lot of kind of different devices. And also, in Linux system, in a server OS area, every week you have to face around 40 CVE problem or bugs. You have to fix them. And also, in your company, maybe the OS team will release update per month or even per week to you. You have to apply those kind of update to your kernel, to your system, to the machine. So they all need you to upgrade kernel. So you can imagine the things, like how big mass the things is. You in charge of a lot of machines. Every day you have facing the problem to update, and you have to do that. So the root cause, what is the root cause? So the root cause is actually the kernel is highly coupling and unchangeable until now. So that is the kernel has developed and we call it a monolithic kernel has this kind of disadvantages. So that means change anything in kernel means change everything. You have to change everything to the whole kernel to update. But it's very difficult for nowadays. Okay, so if the problem is this, in openEuler community, that we have idea that make everything in kernel as a service, we call it CAS, kernel as a service. The idea is very simple. Just we have two kind of way. The first way is we are facing the driver, because a lot of hardware is to have to deal with the driver. For driver, we redesign a driver framework. That means if you develop the new driver conform to the new driver framework, that means we want to make the driver also as a service, which exists in kernel space or even or in the user space. The second part is we want to use the eBPF to make the modules to be flexible and configurable. For example, the network service, the storage service, schedule service, make all of the service. We use the eBPF to build a framework for those kind of, for the network, storage, schedule, or other memory, or something like that. They also to change to be a kind of service. So that is the idea. If you have some policy, you can make configure some policy and compile them and put it into the framework. and the framework will use those kind of policy to run. So that means that can change the kernel to be a reconfigurable kernel. So that is the project we are trying to build. For my assumption that in next year we maybe we can give a POC or prototype release. So welcome and to developer to make a try. So that is the first issue problem we are resolving. And the second one is the gap between the server and the embedded. For the OS, I mean, for the Linux world, there are two kind of two words. One word is the server or the cloud. Another word is the embedded or the edge. For the server side, the people or user often use the Red Hat, CentOS, SUSE, or Ubuntu or something like that. And for the embedded system, we use open embedded system or WR-Linux from openEuler or Yocto system to build the Linux. So, but the two systems are very different. For the server, something are shared. For example, the SUSE and the CentOS use the RPM to build their OS, so the software can shared by the system, but they cannot share those packages to the embedded system. That's where if you build an embedded system, actually it has nothing related with the server side. For example, I don't hear anyone to use Yocto to build the server OS. So that is the two world. When the industry is divided to be two parts, so everyone will pay double effort to do the compliance work, especially for chipset vendor or software vendor, right? For the chipset vendor, you have to provide your product or driver or patch to different world to make the compliance. And for the application, also, it cannot deploy freely among different machines. And also, it's very difficult for the application to migrate from the server to the embedded because it's quite different. So, but if you consider the OS, what is OS? Actually, no matter embedded OS or server OS, every OS is just a collection of packages. If you have a server OS, it's maybe big and maybe contain 4,000 or 5,000 packages. If you have just an embedded system, it just contain maybe 50 or 100 packages and has different features. This is just the difference. So the different OS is just the different collection of packages. So idea is coming. So I think the idea is very simple. So openEuler, we want to build we are a distribution, first of all. It's a distribution. You can find the ISO or image to download, to install. But what we want to do is to make a package pool. So that means we can consider it as the component of OS pool. And we try to build a composed system. So if you want some OS, you can use the composite system to get some packages from the pool to create the OS you want. So that is you can create the server OS like a big house. And also you can create a very small house. So that is the whole idea. What's the advantage of this idea? That means no matter what you build, a server OS, a very complicated server OS, or it is an embedded system or an edge system, they share the same software baseline. That means they share the same kernel, they share the same compiler, they share the same container or virtualization infrastructure. So if you are a vendor, you are a chip vendor, you just need to comply with the package pool. So no matter what kind of the OS is made, you can comply with everything the OS created from the pool. So that is the whole idea. So if we can do some summary, I think in this speech, I bring up two challenges. And the first challenge is the kernel need to be flexible and the decoupling. And the second one is the OS distribution need a unified platform to build OS for different scenario and make the software baseline to be the same, easy for the to reduce the effort for the hardware vendors and the software vendors. So that is the two way that we want to make a try in the openEuler community. So welcome to join us and let's run together. Okay, finally, I think we can do a little bit of advertisement for openEuler because I see someone ask this topic. The openEuler is a kind of distribution, and also I do some explanation. It is kind of a packet pool plus a compose system. And also we want to do more interesting things different. For example, we build some light virtualization framework. We build a lightweight, we use the Rust or C, rewrite the container engine. We have a new GDK. We have some tools to help the security to be more easier. And also we have some POC technology to upgrade the kernel, how to upgrade the kernel or something like that. So we want to make the openEuler as an innovation place for all the developers. So this is the website. You can access the website to get more information about the openEuler. But I think the two challenges I bring up today is I think is a very big challenge for openEuler we try to resolve. So finally, we welcome anyone to join us and make a try. Okay, thank you.